Afternoon everybody, and Happy New Year. I was really looking forward to seeing you next week, but it looks like that's out the window now. Now quite a few of you seem to have stalled on this little section here on Redox Titrations. Those of you that have started this little section, come on, get on with it. You're behind everybody else. Now what I'm going to do is just talk you through the sample question here, and then you need to go away and try the rest. Now I know one of you has actually completed the rest, but can you please make sure that I can see you're working? So let's look at the sample then. This is a fairly typical redox titration question. It would probably be split down into parts. The first part, you'd have to write a half equation for the iron 2 ions being converted into iron 3 ions. Okay, you should all be able to do that by now. The second part would be the conversion of the MnO4- ions, the manganate 7 ions, just in case you haven't got that name yet for earlier in the worksheet. The MnO4-, the manganate 7 ions into Mn2+. Okay, and just a reminder that that equation is MnO4- plus 8H plus 5 electrons going to Mn2+ plus 4H2O. You then need to combine those two half equations to get a full equation, and to do that you multiply the Fe2+ equation right through by 5. So your final equation should be, with all the electrons cancelling, remember, MnO4- plus 5Fe2+ plus 8H+ goes to Mn2+ plus 4H2O plus 5Fe3+. Okay, that's the final equation. Now, how do you go about solving this? Well, it's, as it says above, it's like an acid-base titration. So you know the concentration and the volume of the MnO4-, the manganate 7 solution. So your first step is to work out moles of MnO4-, and that's simply the 0.02. By the way, be careful with your significant figures when answering these questions. 0.0200 times 25 over 1000. Remember, you need that 1000 to convert centimetres cubed into decimeters cubed, because concentrations are moles per decimeter cubed. Okay, so you'll get a number for that. Your next step is then to work out the number of moles of Fe2+. And the moles of Fe2+ are simply 5 times the moles of MnO4-. So you take your answer to the bit above and multiply it by 5. You then need to convert that to a mass of Fe2+, and you do that by taking your moles and multiplying it by the mass of 1 mole of Fe2+ ions, which is, off the top of my head, without a periodic table in front of me, 55.85 grams. So moles times the mass of 1 mole, the AR in this instance, gives you the mass of iron in the lawn sand sample. Then when you've got that mass, you take that mass, divide it by 3.00 times by 100, and you get your percentage of Fe2+ ions in the lawn sand. Now the one thing you need to be careful of is sometimes, particularly in one of the later questions, you've taken 25 centimetres cubed of a solution from a solution of 250 containing the tablet in this instance. So there is a factor of 10 that you need to include later on. So when you've worked out your moles of the tablet, of the iron 2 plus in this 25 centimeters cubed, you then need to multiply by 10 to get the number of moles in 250 centimeters cubed of water that the original tablet was dissolved in. Okay, so just be careful of that. You could need to get a factor of 10 in there to make sure you get the right answer. Okay, so please have a go at these. Please show you're working if I haven't seen that yet. You know, it's fine for you to do it all on paper and send me a picture. Absolutely fine. If you have finished, then please feel free to move on to the next little section, which is just a special example of a redox titration. It's a little bit complicated, and what I'll do is I'll go through that redox titration with you next time. But today's work, and it should keep you quiet for a fair bit of the lesson, is actually to go through all of these sample questions. Okay, if you're completely and utterly stuck, remember there's this amazing thing called email. You can drop me an email. You can even leave comments in Google Classroom, and what we'll do, or what I'll try and do, is respond to those as soon as I can. But obviously it's a little bit tricky. I can't necessarily get on Google Meet with you all because of being in the boarding house. Anyway, good luck with those, and please make sure I see the solutions.